Right, section 2.3 is angle properties and triangles, and section 2.3 starts off with the proof that we did in section 2.2. This time though the statements aren't given to us, so just going to run through quickly in case you didn't look at that video. But basically what you do here is, in order to prove that the angles, three angles in a triangle add up to 180, you would have to first start with a triangle and then construct a line through vertex, in this case vertex D, through vertex D, which is parallel to the base of the triangle, RE. And I'm just going to put a couple of numbers of the angles. Once you do that, you have three angles that are created, and angle 1 plus angle 2 plus angle 3 has to add up to 180 degrees because they form a straight angle. Or straight line, whatever way you want to look at it, but in either case, when you have a straight angle, the measure is 180. So if there's three angles making up that straight angle, then the sum has to be 180. The next step is to, because we've got parallel lines here, we know that we've created alternate interior angles. Angle 1 has to equal angle R because they are alternate interior angles of parallel lines, and so therefore they have to be equal. And angle 3 as well is alternate interior with angle E, so they have to be equal. They're in the corners of the Z formed by the parallel lines and the transversal. And therefore then we can just basically go back to this statement, and instead of saying angle 1, we can replace that with angle R. And instead of saying angle 3, we can replace that with angle, forget my plus sign, angle E. So instead of angle 1 plus angle 2 plus angle 3 equals 180, we can say angle R plus angle 2 plus angle E equals 180. Two substitutions. We made two substitutions there, and that makes us prove that the three angles of the triangle have a sum of 180. And then this property can be used to help find missing measures. If we have a triangle involved and we got at least two angles of the triangle, then we can always find a third one using the sum, the fact that the sum of them have to add up to 180 degrees. All right, so here are some practice examples. In the diagram shown, angle MTH is called an exterior angle of triangle MAT. This should make sense because it's outside the triangle. Determine the measures of the unknown angles in triangle MAT. So if this is 155 out here, then we know that this angle here is a straight line. And I'm just going to put the number 1 there rather than using 3 letters. So angle 1 plus 155 degrees has to add up to 180 degrees because it's a straight line or straight angle. So therefore, angle 1 has to be 180 minus 155 degrees, which is going to be 25 degrees. So I know that angle 1 is 25, and therefore I've got two angles of the triangle MAT now. So therefore angle A has to equal 180 minus the 40 minus the 25, because the three angles of the triangle have to add up to 180 degrees. So 180 take off the 40, take off the 25, should add up to 115 degrees, or should result in 115 degrees. So that's because of some of the angles of a triangle. Oh, two odds. Sum of angles in a triangle is 180 degrees. Okay, the next example, diagram, I don't know why it goes black like that, but you can still see it. Kind of reverses what it's supposed to be. Okay, so I'm just going to have to use a different color here. So we know that this one here, same as the one we just kind of did, that this is 144. So similarly, if I call this angle 1 in here, we know that angle 1 plus 144 degrees has to add up to 180 because they're a straight angle. So angle 1, keep pressing that, sorry. Angle 1 equals 180 minus 144, which is going to be 36 degrees. And once we know that angle, and we already have the 68-degree angle, we know that angle A has to be whatever's left over from 180, because the three angles, AB and angle 1, have to add up to 180 degrees. So 180 minus the 68 minus the 36 will give you what angle A is. 76 degrees. Again, this is some of the angles in the triangle. Have to add up to 180 degrees. And the next diagram here, similar again. So if this is 53, this one in here has to be, back to black again, is 180 minus 53, which is going to be 127. And then this one here would have to be 180, take off the 127, take off the 29, because the three angles of the triangle have to add up to 180 degrees. So we take that off, you're left with 24. Okay, so you're basically just using the idea that these two form a straight line here. So they have to add up to 180. So this is 53, this is just 180, take off 53. And then the three angles of triangle, angle A, the one we just found of 127, and the one we're looking for, angle B, have to add up to 180. So if we take 180, subtract 127 and the 29, we'll be left with angle B. Okay, so we have to look back at the last three examples that we just did, and you should notice a relationship between the exterior angle and the two interior opposite angles. And that relationship is that the measure of the exterior angle equals the sum of the two interior opposite angles of the triangle. And what we mean by the interior opposite is that they're on the inside of the triangle and they're the ones that aren't next to the exterior angle. So for example, in the diagram that's shown here now, just below here, D would be the exterior angle, and A and B would be the ones that are interior and opposite angle D. They're not next to angle D like C is. So now we're going to prove that this is true for all triangles, similar type of triangles. So we're going to kind of basically put into general statements the steps of the proof that we did in the examples we did. So we started off all those examples that we did on the previous page with the exterior angle and the one that's adjacent to it, which was angle C in this case, and we said that they had to add up to 180 because they form a straight angle. So from that, we can say that angle D is equal to 180 minus angle C. And that's just rearranging the equation. So we also know that angle A plus angle B plus angle C is equal to 180 because the sum of the angles of a triangle. So now this is a little bit trickier. Now we're trying to get that D adds up to, it's the same thing as A and B. So let's take the statement we just talked about and see what A and B add up to. So if we just keep the A and B by itself from this equation, we know that angle A plus angle B is equal to 180 minus angle C. So we just rearrange the equation. And you should notice something now there that I've got written there. There might be other ways to prove this, but this is how I'm thinking about it. So if you know that D is equal to 180 minus C, and the sum of A and B is equal to 180 minus C, then we've basically got the transitive property. They're both equal to the same thing. So therefore, got to put in an extra line there. Therefore, angle D has to equal angle A plus angle B by transitive property. So that proof was a little bit harder than the other ones, but you should be able to follow it now that you've seen it. Okay, so that one's a little tiny bit harder. Okay, so let's just practice using that rule now. All right, so if we're looking for some missing measures here, we know that angle B, you can still do it the other way too, I suppose. You could find angle A first using the sum of the angles of the triangle, and then find angle B using, the fact that they add up to a straight line. They form a straight line. So there's all kinds of ways. You can get around using the exterior angle as the sum of the two interior, but let's just use it now and practice it since we just learned it. So angle B is equal to 102 degrees plus 51 degrees, because it's an exterior angle, and the other two are opposite interior angles. So that would mean that angle B should add up to 153 degrees. And angle A, you can either find using angle B, or because B and A have to add up to 180, or you can use the sum of the angles of the triangle. And it's probably just as quick to use angle A equals 180 minus the 153 there, which is going to be 27 degrees. Okay, the next example. We know that x has to be 180 minus the 98, which is going to be 82, I think. Which is 82, because they have to add up to 180 degrees, they form a straight line. And then once I've got x, I know that m is just going to be 180 minus the 70 minus the 82 that I just found for x, because all three of those form the angles of a triangle, so they have to add up to 180 degrees. 180 minus 70 minus 82, which is 28, because they're the sum of the angles in triangle. And then t is, you could either use m to figure it out by taking 180 minus the measure of angle m that we just got, which was 28. So that would have to be 152. Or you could also find m using the sum of the 70 and the x degrees, which we just found. And you should get the same answer. 70 plus 82 is still 152. Okay, the next one. Again, we can use the sum of the angles of the triangle to find x, because x would have to be 180 minus the 54 minus the 50, which should be 76, I think. Yes, which is 76 degrees. and that's the sum of the angles of a triangle. Have to add up to 180, right? And x would have to equal y, because they're vertically opposite, so y, that makes y 76 degrees. Vertically, I'm just going to use VOA for that, vertically opposite angles. And then I've got, again, t. You've got two angles in the triangle, so t would be 180 minus y, which is 76, minus the 67. Which is 37 degrees, using the sum of the angles of the triangle again. It's supposed to be angles up there. That doesn't look much like angles, does it? Looks like letters, number 6 next to it. Okay, so some of the angles in the triangle. Okay. Question number 4, you've got some parallel lines there now, so that might be helpful in getting z equal to 45, sorry, not 48, because they would form alternate interior angles of the parallel lines. And so once I know that, I'll just write that down, alternate interior angles of parallel lines. And by the same reasoning, y has to be 53, because they're alternate interior angles using the other transversal. So I'm just not going to write all that out again, I'm just going to say ditto. And then the x can be found by using the sum of the angles of the triangle. So x would equal 180 minus the angle of 53 degrees minus the angle of 45 degrees, because that's what z was. And that gives you 180 minus 53 minus 45 is 82 degrees. That's the sum of the angles. And the next one here now, again, has parallel lines. So if we see if we can use some of our relationships there, we can get that x is equal to 53, because they're corresponding angles of parallel lines. So they have to be equal. And we can't get y right away, but we can figure this one out, even though it's not marked. We know that this has to be 76 for the same reason, it has to be corresponding with the 76 that's down here. So these two have to be equal. And then we can get that y is equal to 180 minus, whoops, not equal, sorry, minus the 76 minus the 53, because again they're all angles in a triangle, so they have to add up to 180. So 180 minus 76 minus 53, which is 51. And the last example here now asks you to find angle NMO. Remember the middle angle is where the vertex is, so we need to find this one. I'm going to call that angle 1. And angle MNO, M to end O would be this one here. And angle QMO would be this one right here. So we need to find all three of those angles. So we've got some parallel lines. And I'm just saying this is an alternate interior angle with these two together. So I know that angle 2 plus 20 degrees has to equal 67 degrees, because they should be alternate interior angles. My pen is giving out, I think. So therefore angle 2 should equal 67 minus 20, which is 47 degrees. And if I know angle 2, then I can get angle 1, because angle 1, angle 2, and 39-degree angle, right here, have to add up to 180 degrees. So angle 1 would be equal to 180 minus angle 2, which was 47, minus the 39 degrees. 180 minus 47 minus 39. And there may be more than one way of doing this. It kind of depends on what you see first, I guess. And then we've got angle 3 left, which is an exterior angle. Oh, no, it's not. It's not an exterior angle of that triangle because it's not made with the side of the triangle. It wouldn't go, it doesn't go, it's only a piece of it there. So what can we use to get angle 3? Oh, angle 1, which is 94 degrees. Yeah, 67 degrees. Angle 3, let's write that down again. Angle 3 and angle 1 and 67 have to add up to 180 because they form a straight line right here. So that means angle 3 is 180 minus the 67 minus the 1. Which was, angle 1 was 94, so minus 94, which is 19 degrees. So angle 3 would have to be 19 degrees. There's some questions there now that you can try in the textbook to practice these. And the more practice you do, the more efficient you'll get with the angle properties.